Good morning everyone. So the last class we started the complex numbers. The introduction part is going on. Some introduction part is given in the last class. The continuation will go direct. I will recap it the last introduction part. I told what is a tree diagram of complex numbers, and next what is meant by complex number. A number can be expressed in the form of a plus ib, where a and b are real numbers, which is called as complex number. It is denoted by either C or Z. Usually our textbook it is denoted with Z. So now onwards we will see that complex, whereas Z is represented with a complex number. Is it correct or not? So in Z is equal to a plus ib, Z is equal to a plus ib. It is a general form of a complex number. This a is called as a real part of Z, and b is called as a imaginary part of Z. Imaginary part of Z is b, real part of Z is a. I told generally if some complex numbers you can see Z is equal to suppose 3, Z is equal to 4, Z is equal to 1 by 2, Z is equal to minus 1. These are all belongs to a real numbers. If you take the real numbers in the complex numbers, real numbers is also a complex numbers. Why? Because real numbers are subset of complex numbers, but these we have the specified name. Why? Because Z is equal to 3, we want to explain it is I times of 0, then only it is in the general format. What is general format? A plus ib. Suppose another, this is Z1, another Z2 is given as root 3. I can write as root 3 plus I into 0. If Z3 minus 1 by 2, I can write minus 1 by 2 plus I into 0. Now these are all complex numbers only, but in this complex number the imaginary part is 0. That's why it is called as pure real numbers. Purely real numbers. Is it correct, students? Like imaginary numbers are there. What are imaginary numbers? Z is equal to some I, Z is equal to 2i, Z is equal to minus 1 by 2i, Z is equal to minus root 2i. These are all imaginary numbers. The representation of I told already. What is the necessity of I means some quadratic equation may get the roots into the square root of negative real numbers. For that purpose, first we took the one quadratic equation x square plus 1 is equal to 1, x square is equal to minus 1. So x is equal to root over minus 1. Under square root, these numbers only positive real numbers exist. Till now we calculated only that. Now negative real numbers also exist. Based on that, this x is equal to root over minus 1, we are denoting with one letter which is called I. This form is iota. It is a Latin name. It is given by Euler scientist. Okay na? So the now onwards you are representing any number with I, 2i, 3i, 1 by 2i, 4i. These are all under imaginary numbers. Imaginary numbers is also part of complex numbers, because I told a tree diagram, you can recall it, the first video, you come to know that. But these are also complex numbers, but in this complex number, if you want to write Z is equal to I value as 0 plus I, then only it is Z is equal to A in A plus IB format. So here the real part is 0. Here also the same, real parts, all real parts are 0. If the real part of Z we will denote it as mathematically RE open bracket Z. If real part of Z is 0, such complex numbers are called as purely imaginary. These are purely imaginary. If imaginary part is 0 here, imaginary part of z, we will denote it as mathematically like this. Im open bracket z, nothing but imaginary part of z is 0. Such complex numbers are called as purely real. So it is also complex numbers. These are also complex numbers. These are also complex numbers. But in this complex number, it is not satisfying fully both parts. One part is exclusively 0, whether imaginary part 0 or real part 0. If imaginary part is 0, such numbers are called purely real numbers. That's why real numbers is also a complex numbers, because of real numbers are subset of complex numbers. Like you can observe all imaginary numbers whose real part is 0. Those are called as purely imaginary numbers. So imaginary numbers is also part of complex numbers. That's why imaginary numbers is also complex numbers. But if imaginary real part of z is 0, specifically we will call as those are purely imaginary. Then we will take the z is equal to 0. What about 0? 0 is it has real part is 0 as well as imaginary part is 0. 0 I can split like this. Real part of z is 0, imaginary part of z is 0. Both real and imaginary part both are 0. That's why it is called as purely real and imaginary number. Clear, students? Right. Our present topic. I told these complex numbers are represented in the certain plane, the named as Gaussian plane, Argand plane or complex plane. What it represents? I told already, in this plane represents the horizontal axis as real axis and vertical axis as called as imaginary axis. Real axis and imaginary axis. So real axis we will denote it as real numbers like 1, 2, 3, 4, minus 1, minus 2, minus 3. Whereas imaginary part is imaginary axis is denotes with imaginary numbers like I, 2i, 3i, minus I, minus 2i, minus 3i, like that. So now we'll come to our next part. If generally two complex numbers are not equal. For example, a plus ib never equal to c plus id. This is one complex number, this is another complex number. Generally, two complex numbers are not equal. Peculiar cases, if they are equal. Suppose if they are equal, what is the condition? Yes, their real parts are equal and their imaginary parts are equal. What does it mean? Real parts are A and C and imaginary parts B and D. So you remember, very important note, imaginary part lo don't consider I, only the quotient of I with sign you have to consider. It is a plus sign, no problem. B is equal to D is imaginary part, A is equal to C is a real part. Clear, students? Generally, two complex numbers are not equal. If they are equal, they should obey this condition. A is equal to C and B is equal to D. Why we will say all these? You know that number system except complex numbers are all, how they are equal, how they are less than, how they are greater than, how make it a square, what is its square root, what is its modulus, that's all you learnt. This is a new number system, complex numbers. That's why we have to learn from the basic level. And one more important point, two complex numbers never follows greater than and less than condition. Suppose if you take number system 3 and 2, obviously which sign we will put in these two numbers? We will write 3 is greater than 2. Greater than symbol can be exist. Suppose minus 2, 5. Minus 2 is smaller than 5. Whereas if you consider two complex numbers a plus ib and c plus id, we cannot use either less than or greater than. We cannot use. If you use this is wrong notation. Why? Because if 3 plus 2i is given, 1 plus I is given, we cannot use this symbol. Why? Because we don't know this value. This is a just complex number. We don't know this value. Because I value we can substitute and simplify. We cannot use in between complex numbers less than and greater than. We can use equal. We have one condition. When we have to use equal, if two complex numbers are equal, then their corresponding components, that means real parts and imaginary parts are equal. But if two complex numbers, we cannot represent always either less than or greater than. That is wrong notation. We should not use less than or greater than conditions. Keep that in a very, very important thing. Clear, students? Right. Next, apart from the complex numbers, we have the I value, iota. Already we discussed about iota. I is equal to root over minus 1 I told. If you make square on both sides, what you will get? I square is equal to minus 1. Is it correct or not? Squaring on both sides. I square, square and root gets cancelled. Suppose we want to calculate I3. I can split as I3, I square into I. I square value known is minus 1. Minus 1 into I. That is equal to minus I. If you want to write I power 4, I can write I square into I square. I square value known is minus 1 into minus 1, it becomes plus 1. This is the cycle of I. What is meant by cycle of I? It will be repeated. Just you see that I will draw one diagram like a circular cyclic process. If it is I square is, this is I square. I square value you know very well, minus 1. I cube is, you are getting as minus I. Minus I. Next I power 4 is 1. This is the cycle of I minus 1 minus I plus 1. That means I square, I cube, I power 4. Next I power 5 means the same answer. You can simplify it. I power 5 is equal to I power 4 into I. What is I power 4 value? 1. 1 into I, that becomes I. Again you will get I only. I power 6. I power 6 I can write I power 4 into I square. I power 4 is 1 and I square is minus 1. 1 into minus 1 becomes minus 1. You will get again same value. You want to check the I power 7. I power 4 into I cube. Bases are equal, exponent should be added. I power 4 is given 1. I cube value already we calculated minus I. Again you are getting minus I. If I power 8. I power 4 into I power 4. 1 into 1. Again 1. You will get this. That means I value you are going to increase. It will be rotated on the circle only. It cannot be get more other value. By all this, we concluded one general formula. You see that general formula. I to the power of 4n. What is meant by 4n? If n is equal to, we are taking as any whole number or positive integer. If I took n is equal to 0, 4 into 0, 0. I power 0. Anything power 0 is 1. If you substitute n is equal to 1. it becomes 4 ones are 4, I power 4, 1. If you substitute 2, I power 8, 1. If you substitute 3, I power 12, 1. If you substitute 4, I power 16, 1. So I power 4n is always 1, where n is equal to 0, 1, 2, 3 and so on. Those are nothing but whole numbers. Correct or not right? Let I am taking I to the power of 4n plus 1. What does it mean? 4n means nothing but multiples of 4. Multiples of 4. If I power as a multiple of 4 means exactly divisible by 4, that answer will be always 1. For example, now the running present here is I power 20, 20. It is exactly divisible with 4. How many times I can write 4 to the power of 4 into 505? Is it correct? 4 5s are 20, 4 5s are 20. I can write it is I to the power of 4 whole to the power of 505, 505. A to the power of m whole to the power of n, a to the power of mn. I to the power of 4 value is 1. 1 power anything is 1 only. So now you can understood clearly, any number we are expressing as I to the power of 4 into n. Here n value is 505. No problem in that. Correct, students? If you go like this, I to the power of 4n model, any problem will get. That means I power, whatever the number is given, if it is in hundreds, thousands, whatever the number is given, if it is exactly divisible with 4, that value is 1. I power 4n plus 1, what does it mean? If you divided with 4, you are getting remainder 1. For example, I to the power of 2019, 2021, next year. I can write it is I to the power of 4 into 505 plus 1 remainder. Correct or not? I can write it is 4 into I to the power of 4n plus 1 format. I can simplify this is I to the power of 4 into 505 plus into I to the power of 1, a power m plus n, a power m into a power n. So this already we calculated here 1. So 1 into I you are getting as I. So I to the power of 4n plus 1 is always getting I. That means any number, if you divide with 4, you are getting remainder 1, that value becomes I, when that number should be in I to the power. Like I to the power of 4n plus 2. What does it mean? If you divide with 4, you are getting remainder 2. That value is always minus 1. For example, if you take as 2022, not only that, you can take I to the power of 10. I can write it is I to the power of 8 plus 2. Correct or not? This I to the power of 2 into 4 plus 2. I to the power of 4 whole square into I square. This is 1 square, 1. I square is minus 1. So the total it is minus 1. So 8 I can write as 4n times, n place is 2. So if it is 4n plus 2, we are getting remainder 2, that value becomes minus 1. I to the power of 4n plus 3, what does it mean? If you divide with 4, you are getting remainder as 3. Suppose 2019, last year. If you divide with 4, you are getting as a 3 remainder. Correct or not? In that cases, this value is becomes minus I. That's why it is a general formula for I. Whatever the number is given I exponent, it is exactly divisible with 4, your answer is 1. It is divisible by 4, getting 1 remainder, your answer is I. It is divisible by 4, getting 2 remainder, minus 1. It is divisible by 4, getting remainder 3, minus I. Excuse me. Now this is called general form of complex number. Any 4 consecutive I powers, for example I square, I cube, I power 4. These 4 are consecutive terms of I, correct or not? Power will be I power 1, I square, I cube, I 4. If you simplify this, I value becomes I told I square value is minus 1, I cube value is minus I, and I power 4 value is plus 1. It can cancel everything, we are getting as 0. That's why consecutive I values sum is always 0. So these are also consecutive, 4n plus 1, 4n plus 2, 4n plus 3. That's why this is very very important question in objective. I to the power of 4n plus I to the power of 4n plus 1 plus I to the power of 4n plus 2 plus I to the power of 4n plus 3 will gives always 0 answer. You can substitute these values, plus 1 minus 1 cancel, plus I minus I cancel, you are getting as a 0. This is the I cycle. That means I to the power of whatever the number is given, I to the power of 2, 3, 4, 5, 6, 7, 8, this is given. What is its value? Very simple. This number is divisible by 4 or not. You know that lower classes divisibility test for 4. Last 2 digits are divisible by 4, then it is divisible by 4. Is it possible? Last 2 digits? You can divide it. 4 ones are 4, 38. 4 nines are 36. So it is not exactly divisible. How much remainder you are getting? 2 remainder. Correct or not? That means 4n plus 2. If it is in 4n plus 2, what is your answer? Minus 1 is your answer. Like that, however the number, which is large number also, we can simplify in easiest way. Clear, students? Right.